We are moving on to chapter 5 with lesson 5.1, talking about perpendicular and angle bisectors. So before we can do that, we need to write down some definitions here. So first one I want you to write down is the word perpendicular. Now, have we seen this word before?
Yes.
Yes. Okay. What do you remember perpendicular means?
Across from.
What?
Across from something.
They cross each other, specifically how?
Intersect.
90-degree angle. Yep. So the definition is two lines that intersect and form a right angle. What do we know about a right angle? 90 degrees. If I draw a picture here, I have two perpendicular lines. Remember, that's the symbol for perpendicular there. They form a right angle. Okay, so that is perpendicular. Nothing has changed there from what we've talked about in the past. Okay. Next definition is the word angle. Yes, we all know what an angle is, but do you know how to define an angle?
It is a certain degree that lines intersect at.
That's a very good try, and it's very close. Okay. We're gonna say two lines. That was a very good example there. Two lines that meet at a corner. So remember, whenever I have you make an angle with your hands, everyone make an angle with your hands real quick after you write this. Yep, making an angle with your hands, it's those two lines that meet at a point at the corner. Okay, so if I draw this as a picture, okay, here are those two lines. They create this angle right here. What are angles measured in? Degrees. Yep. Okay, and then one more minor definition here that we have also seen before is the term bisector. What's a bisector? It splits it in two, yes. So definition for that, I'm going to scoot up just a little bit. It says a line that intersects an angle or a line and splits it in half. So remember, when it splits it in half, we can say then we have two equal parts. Do you agree? When we say something split in half, we're left with two equal parts. Okay. These are the three definitions we are going to use today. Okay, you do not have to draw these arrows that I'm about to draw, but we are going to talk about a perpendicular bisector, and we're going to talk about an angle bisector. Okay, so we're going to talk about those two things there. So what I want to talk about first is our perpendicular bisector. Okay, so first one I'm going to draw a picture of. You can put this in your example 2 space. Okay, this is going to be a perpendicular bisector. Okay, perpendicular bisector. Okay, and this picture that we're about to draw, you can draw it fairly large. But I want to put a definition with this first, or an example. I'm going to say line XY is a perpendicular bisector of AB. Let's draw a picture that matches this. Okay, so here is, let me draw it a little bigger. Here is my line AB. Draw this picture fairly large for yourself. Here's my line segment AB. And here is my line XY. Okay, let's break apart the term perpendicular bisector. What does perpendicular mean? Intersects at what? Right angle. Yep, so we can create a right angle here. Do you agree the other side is also 90 degrees? Okay. What does bisector mean? Splits it in half. So what's being split in half here then?
The line.
Which line?
The A to B.
A to B. Yep, so do you agree I can say AY is congruent to YB?
Yeah.
Okay? That is a perpendicular bisector. Now I'm going to add something here. Okay, what if I added a line from X to A and X to B?
It's a triangle.
It does make a triangle. What else can I say about those two lines that I just drew?
They're congruent.
Why? Oh, I like that. We could say hypotenuse because they're across from this right angle, right? Okay. I agree with that. What did you say?
They're congruent.
We can say they're congruent to each other. Does anyone know why?
Because there's a 90-degree angle on the two lines below it. Oh wait, because the two lines below it are congruent and they point at that one, right?
Correct. The two lines below are congruent. Aiden, what did you say over there? Connected where? Yeah, so I want you to draw this arrow right here. I want you to make a note that they meet at the same point. Okay, so just pay attention up here real quick. At the beginning, we said XY is a perpendicular bisector. So we knew this right angle happens, and we knew these two sides are congruent to each other. Well, if we go from our point A and point B up to a common point X, those two lines are going to end up being congruent to each other. Okay, and we also said that this is also 90 degrees over here. Okay, one minor definition I want you to write here. Yes, we know AX is congruent to BX, but what I want you to say is that AX and BX are equidistant. What does equidistant
They're
mean?
an equal distance from the
That's exactly right, right? Equidistance means they have equal distance. Do you agree that equidistant and congruent can mean the same thing? Yes. Okay. So you are going to see a lot of pictures that resemble what we just drew there. Okay, with a perpendicular bisector and then two lines that meet at the same point. Okay, I also kind of want you to draw this counter example here. So if I have a perpendicular bisector, that was a really bad line. Okay, we have a right angle. I know these are congruent to each other. What if I drew a line from here to here? Are those two lines congruent to each other? Those two black lines that I just drew, are those congruent to each other? Why not?
Yeah, they don't have the common point.
Right, they don't meet at the common point here. So if you drew this, awesome. Go ahead and circle this. Okay? Do not meet at a common point. So can we say they're equidistant? No, so we could say they're not equidistant. Okay, so that is everything you need to know about a perpendicular bisector. Okay, so I want to look at some examples here that we can apply what we just learned. Yes? So looking at this picture, very similar to your example 2 picture, what are some things that you notice just by looking at the image?
It has the common point and it has the equal distance.
Yeah, it has the common point, and this means they're congruent to each other, right? What else do we have? What's PQ? What's that line there?
Bisector.
It's the perpendicular bisector. Label this in your notes. That's our perpendicular bisector. So, knowing that information and the two sides are congruent to each other, what else can we assume about this image?
The two sides. Oh no, I'm not splitting.
Mm-hmm.
Wait, yeah, we can, right?
Mhm.
They're congruent with two triangles.
Yeah, XY has to be congruent to QY. Are those two triangles congruent to each other?
Yeah.
By?
Side. Is that one?
Hypotenuse leg. Yes, hypotenuse leg. Would side also work?
Yeah.
Because we have this common side, right? Yep. Awesome. When you're ready, go ahead and flip to example, the next page. It's actually example 6.
Why did it skip example?
So I'm going to take a Whoa. I am having troubles. Okay. This one's not in your notes yet, but I do want to take a look at this. I just want you to follow along here. Looking at that image there, okay, what can we say about AC?
It's the perpendicular.
That is the perpendicular bisector, okay, because we know these two sides are the same. So then, what else can we assume?
That the other two lines that meet at the common point are not congruent.
Correct. These would also have to be the same then, right?
Yeah.
So how can I set this up to find the value of x? If I know those are the same. What can I do to these two if I know they're equal to each other?
7 equals something. I don't know what that.
Correct. Say what I want to, or sorry, do what I say, right? So if I say these are equal to each other, I want to set them equal to each other. Yep. How would I solve this here? Anybody? Add 10, okay. So I get 6x equals 3x plus 12. Next step here. Subtract 3x. So I get 3x equals 12. What would my last step be? Divide by 3. X equals 4. Awesome. If I wanted to know the actual length of AD, what would I do here? If I wanted to know this actual side length,
You put 4 in for x.
I would plug 4 in for x and solve. Yes. So, using that, I want you to try example 6a and b. Looking at example 6a, what are some things that you notice, or what's some things that we can assume? This is a perpendicular bisector, so what else should that line do? Since these two lines are congruent here, what else can we assume? These two lines have to be congruent to each other. So what is a way I can set this up then? Set them equal to each other. Yep, so 2n plus 7 equals 5n minus 2. How would I solve this?
2n.
I heard add 2 first. So I can do 2n plus 9 equals 5n. Brayden, what did you say we could do? Subtract 2n. So we get 9 equals 3n. Last step. Divide by 3. We get n equals 3. Is that what that example wanted?
No.
No. What do we have to do to find wy?
W.
To find the length here.
You have to put 3 in.
Yep, we're going to plug 3 in for n here. So if I take 2 times 3, what's that?
6.
Yep, what's 6 plus 7?
13.
13. Get it out. Get it out of your brain.
It's 6 or 7.
It'll die soon enough.
No.
Like Liam?
Part B. Let's look at part B here. It wants to know the value of OL. So OL is here. Okay, remember, there's a lot of things going on in here, right? We want to take everything one at a time. Okay, so what are some things that you noticed right away?
Perpendicular bisector.
You saw the perpendicular lines. Okay, what else did you notice right away?
There's no 14.
Did you notice that these two are the same?
Yeah.
Okay, so since those two are the same, what else can I assume?
The one on the right.
These bottom ones are the same. So if this is 14, what does this one have to be? Also has to be 14. Good. How did that help us there if I zoom in a little bit here? If I know this whole line is 14, go for it, Claire.
Half of it, because of the perpendicular bisector.
Yep, this is a perpendicular bisector because we know these lines are the same. So these two have to be the same. What does that have to be? If the whole line's 14, how do I find half of that?
Divided by 2.
14 divided by 2 is
7.
7. Yep, so your answer for part B is 7. All right, on your example 7, I want you to write this last definition here today. Okay, now we're going to talk about an angle bisector. What do you think an angle bisector is? For our picture here, I'm going to say BD is an angle bisector of angle ABC. Okay, so I'm going to draw this picture to match. So I have angle ABC, and BD is an angle bisector, so I'm going to draw that line right here. So labeling some things, here's my point A, Here's my point B. Here's point C. Point D is going to be right in the middle there. Okay. What do you think an angle bisector is?
In the middle.
Right. BD's our angle bisector. What does it do?
Splits an angle.
Splits the angle in half. Yep. So we know this half has to be congruent to this half. Okay. If I drew two perpendicular lines here, go ahead and draw those. What do we know about those two lines?
They made triangle.
They do.
They do make a triangle.
They're a perpendicular bisector. They split it, kind of.
They do make a perpendicular line, but is this side equal to this side?
No.
No. Okay, but what do I know about these two lines right
They're
here?
congruent
Why?
because they both have 90 degree angles on the side.
Correct. And what do you know about their angle measures?
It points at the congruent angles.
The angles are congruent. So remember when I had you make the angles with your hands?
Yeah.
Okay, if you and the person sitting next to you have the same angle measure, what do you know about the side across from that?
It's congruent.
Has to be the same, right? Because if I move my angle, that changes the side length, yes?
Yep.
Yeah.
Okay, so that is an angle bisector there. So remember, if you know that these two lines are congruent to each other, we can assume the angles have to be congruent to each other. Yes?
Yes.
If we know the angles are congruent to each other, we can assume the lines are congruent to each other. Okay. What is important about this? That we'll usually have it in every drawing. We have to have these right angles here in order for both of those to be true. Okay, so those have to be perpendicular to the walls of the angle. Okay. So knowing that information, I want you to go ahead and try example 8A and B. Okay, looking at this example first, what are some things that we can assume, or what are some things that you see? Right away, I see that these two angles are congruent to each other. What does that allow us to assume then?
What you said, the angles are congruent, then the lines are congruent.
How do I know the angles are congruent to start?
Because they have the two lines.
They have the markings, right? So what can we assume about these two lines?
They're congruent.
They have to be congruent to each other. How can I set this up to find the value of x?
Set them equal to each other.
Yep.
And solve it.
So 2x plus 3 equals 4x minus 11. What's a step I can take?
Add 11.
Okay, add 11. So I get 2x plus 14 equals 4x. Next,
You can subtract 2x.
subtract 2x. We get 14 equals 2x. Last step here.
Divide 2.
Divide by 2. We get x equals
7.
7. If I wanted to find the length of KL, what would I do here? I would plug 7 in. Yes. So on example 8A and B, it gives us information. What should we do with that information? Should we just look at it? What should we do? Put it in the picture. Mark it. Yep. So it says HI is 7 and IJ is 7. So what do you know about those two lines? They're congruent. Okay. And it tells you HGI, this angle here, is 25. It wants us to find IGJ, which is here. Looking at that image, since those two lines are congruent, what can we assume?
The angles are congruent.
The angles have to be congruent. So if this is 25, this angle has to be 25. So your answer for A is 25. Okay. I'm going to erase. Let's look at example B. It tells us that HGJ is 57. Is that the whole angle or just a part of it?
That's the whole thing.
That's the whole thing. Yep. So I can kind of mark it like this. The whole thing is 57.
Or I put it on the outside, but IG.
You can do that too. And it tells you IGJ is 28.5. So this angle here is 28.5. And then more, it gives you HI is 12.2. It wants us to find IJ. Ideas.
They're congruent.
How? Because this just says 57, this says 28.5.
You have 57.
Yeah, we want to prove that, right? So in order to find this here, we can take 57 divided by 2, which is,
28.5.
so did we just prove that these are equal?
Yes.
Yeah.
Yes. So then what can we assume about the lines here?
I do.
They're congruent.
They're congruent, so IJ has to equal
12.
12.2.